So when we're solving the quadratics, if we choose to use the calculator, which is my favorite on this by far, what I'm going to do is I'm going to take each side of my equation, and again, I'm not going to use things like n and all these other things. I'm just going to use x for everything, except I got to be in y equals. That would help me. So 12 minus x. And then the other side of my equation is just x. Okay. The one thing is I always have to have my radical isolated. So we'll talk more about that when we get down to number 4, because there's one little tweak I'm going to have to make. But otherwise, put each side in. We're going to go ahead and we're going to graph it. And I'm going to notice how many intersections there are, if there are any. Well, here I notice there's one. It's right there. So normally, most teachers would sit there and say, okay, we have an intersect option with this, which is back to our same table we always use, second and trace, where we've done the zeros and the mins and the maxes. Well, we're sort of working our way down the list, because now we're going to go down to intersect. I want to know where these guys intersect. So, as usual, there's our little cursor guy. He's just telling me he's up here on this curve, so anywhere is fine. I'm going to hit enter, and then you'll notice he moves. And you're like, ooh, there he is. Now he's down here instead. Okay, just hit enter again. And our guess, I can hit enter or I can try to get close. But here's the thing you've got to watch for. You only need the x value. Make a note of this. Okay, we only need the x value for an answer. So here, my n value would equal 3, and that's pretty easy to check even. Square root of 12 minus 3 is 9. Square root of 9 is 3. Okay, I'm good. I'm done. So you're like, ooh, I don't even have to show work on this. No, you don't. But here's something that you may want to be aware of too if you're using the calculator. If you don't want to hit all the buttons to play with the intersection, there's another way to do it. Once I graphed it, so if I just went back to y equals and I'd hit graph, if you go to the table, maybe, there it goes, and you know approximately where that intersection is, because like you're looking here and you're like, yeah, it looks like it's around 3 or 4. Go look at your table. If you find a place in the table where both of your y values are equal, okay, just the y values have to be equal, then that x value is your answer. And that's another way you can do it with these. So if you get worried about hitting all the different buttons and trying to figure out where's this at, where's that at, don't worry about it, okay? You can do it this way. Well, what if I didn't have a calculator available to do this with? Let me tell you. Now, I don't think some of you are going to want to do this after I show you once, but maybe some of you will. If I was going to do it algebraically, I'd get rid of my radical first. Then I'd work on getting all my terms to the n squared side, because we're going to do some factoring. So I'd add the n over, and I'd minus the 12. And once I have everything on the n squared side, I'd factor it. You're like, holy cow, Harty, this is a little bit longer than just pressing a few buttons in the calculator. And you're right. And you're like, but wait a minute. I thought you said there was one answer. I just got 2. Here's the other kicker about doing it if you're going to do it algebraically. You have to check your answers, because you may get 0 answers. You may get 1. You may get 2. You don't know. Well, we already plugged in 3. We know that works. So check. If I was checking -4, though, I'd have 12 minus -4, which would be plus, equals -4. You're like, oh, I see what's going to happen. The two sides don't equal at the end. So I'd have to check both the answers to see if one of them didn't work, maybe both of them work, maybe neither of them work. Which is the other nice thing about the calculator. You're visually going to see if there's an answer or not. So again, I'm not going to force you to use the calculator, but I really think when you start looking at it, it's going to be worth your while to do it that way. So let's kind of play around some more here. I got negative 24 plus 10x, and I just got x. And I graph it. And I'm looking at this and I'm going, well, it might cross at more than one place. I'm looking here, ew, I'm not really sure. Now, I could play around with intersect if I wanted to. And you're like, well, wait a minute, there's no cursor anywhere. What's up? Well, what's happening is the cursor normally starts somewhere over here. Notice my curve here doesn't start over till almost 3. So I'm going to have to arrow over, there he is. Then I can go ahead and hit enter. And then my second curve's up. And I can just hit enter and I find out one of my answers is 4. But is there another one? I don't know. So if I want to check to see if there's another one, I got to do this whole thing again. So you're going to start learning quickly with this. Now let's see, am I on the curve of the straight line? I am on the curve, okay. So I'll just hit enter. And I'm down here further because I'm thinking my other answer would be down here somewhere. Ooh, and there was another one. Okay, sometimes that's going to be hard to see because, I mean, that's all jumbled up. You barely can see where it's at. This is where, again, it might be smarter to go to the table and then say, oh, the y values are the same. Now, will they always be the same as the x? No. But as long as they're the same, that x value is one of my answers. As long as the y values are the same, the x is my answer. So that's an option that you have as far as figuring out solutions. Now, I've mentioned there might be 0, 1, or 2 solutions. You've seen a 2. You've seen a 1. Now, let's show you what a 0 might look like. So one more to play with here. If I physically look at this one, I can visually see this curve stops right here. They're never going to cross. So if you can visually see that, you can just go no solution right away, or at least you're not going to get any real solution. Now, if you really want to double check, go ahead and scroll through the chart for a little while and see if you get any values that match up for both y's, and you're going to find out you don't. If you did this algebraically, that's going to take a long time. So again, I'd suggest that you don't go that route. And then my only other suggestion that would be a necessary thing is that you want to isolate your radical terms before you put them in the calculator. So on a problem like 4, you're going to want a -2 to both sides first. Then you can feel free to go ahead and pop that into the calculator. Oops, I don't need a double parenthesis though. Okay, make sure I'm being accurate here. Yes. Okay, I see they cross this time. Looks like right about here. So I'm looking at around, I don't know, 5 or 6 maybe. Let's see. There it is. My y values are the same. So their intersection point would be at 6. And if I wasn't sure, let's see. 6 minus 2 is 4. 18 minus 2 is 16. The square root of 16 is 4. All right, I'm good. That's all there is to this. Because I really want you to keep it simple and try to stay away from the algebraic, because that just takes a while. And when you're testing, you really don't want to take up that kind of time. So again, stick to just the evens on this. And what I'm going to do when you come in, actually, I'm going to hand you the little mini checklist tomorrow. Instead of having you come in Friday and do a regular homework check where you're filling in numbers and it's taking time, and which you're going to need to be working anyway, I'm just going to give you the checklist. I'm just going to have you staple it to it. When you walk in Friday, just throw it in the tray and I'll look through things thoroughly instead of having specific questions that you're writing down for this particular check. So this homework check's only going to be 3 things. It's It's going to be the 5-6 bookwork, last night's stuff, and then the practice on this, just the evens. And then the rest of the time, you're going to have to be working on